Now we are on Theorem 7. Theorem 7 says a tangent to a circle is perpendicular to the radius at a point of contact. Now first, what is a tangent? A tangent is a line that touches the circle only once. So in this case, we have ABC as a tangent and it touches the circle only once at B. It continues to say a tangent to a circle is perpendicular to the radius. So here we have a radius OB. This radius is perpendicular to our tangent ABC, which means angle B1 is equal to angle B2, and they are all equal to 90 degrees. They are perpendicular. And don't worry, this theorem is not examinable, so they can never ask you to prove this at a test or an exam. Let's look at the converse of Theorem 7. It says if a line is drawn perpendicular to a radius at a point where the radius meets the circle, then the line is a tangent to a circle. So you are told that if you have a line that is drawn perpendicular to the radius at a point where the radius meets the circle, then that line is called a tangent. And the reason that we use for this theorem is tan perpendicular to radius, which means tangent is perpendicular to the radius. Let's look at an example. So here it says calculate the value of the unknown angles. We are asked to calculate x, and in order for us to find x, we have to find b. So OBT is equal to 90 degrees, and the reason is tan perpendicular to radius, because we have a tangent and that is perpendicular to our radius. So that line, so at B is equal to 90 degrees, and the reason is tan perpendicular to the radius. So we can calculate x. If we add 50 plus 90 and plus 40, they add up to 180 degrees, which is the sum of the angles of a triangle. So x is equal to 40. So in this example, the first thing that I see is what comes from Theorem 3, which is a diameter. So we are asked to calculate x and y. So ABC is equal to 90 degrees, and the reason for that is tan perpendicular to a radius. So what I also see here is an exterior angle. No, sorry, I don't see an exterior angle. In order for us to find x, we already know that ABC is 90 degrees, so x is equal to 55 degrees, because at B, it's 90 degrees. So we have 35, which can be our B1, and we have x, which can be our B2. So if you add 35 and 55, they'll give you 90 degrees. In order for us to find y, I see a diameter here, and you remember what Theorem 3 says. It says if you have an angle that is subtended by the diameter, it is equal to 90 degrees. So here we have a diameter and an angle that is subtended by this diameter, which is y. So y is equal to 90 degrees. And we have to calculate z. We can calculate z using the sum of an angles in a triangle. So if you add 90 degrees from y and you add 55 degrees from x, and then you can find that z is equal to 35 degrees, because all of them, they are equal to 180 degrees, which is the sum of angles in a triangle. And that's it for Theorem 7. Please like the video. Please comment on which other topics you would like me to post about, and please subscribe. I would really appreciate that.